Every single thing we know about air today is based on previous discoveries.
I would personally say it would start with fire. So then the next step to that is, well, what can I use fire for? And what can I use air for? And then you end up into all kinds of things.
Something seems wrong that we can put men on the moon, but not figure out these problems in ventilation. The more you dig into this industry, the more you realize how technical it is and how challenging the problems are to solve. 5 years ago, we did not have variable speed compressors, and we did not have variable capacity refrigeration. That technology has changed the way we think about delivering air to the space. And what we realized is we needed to have a better product offering to control more of the building to have a perfect outcome.
There's no point having a brand new product like DOAS and then you're just putting old-fashioned spiral duct on there that's not necessarily being specified correctly, that's still pushing that air through old diffusers, old registers, and just old technology. We need to be more precise than that. And we just felt like our single V-band concept with the stainless steel was very aesthetic. It's a very simple product, very easy to install.
During our first test, a lot of air wasn't leaving the duct right at the discharge of the fan. So we were wondering why that was.
And we decided that we wanted to see what was going on. So pretty early in the game, the CFD was done.
One thing that CFD helped us realize is the velocity bounds. It's very hard for air to take a 90-degree turn. You actually have to force it out. So if the air is going too fast past those holes, it never comes out of the holes. We didn't know that until we looked at CFD and saw spikes and dips and valleys in the velocities.
Learn from these experiences and just keep moving the product forward until you understand what's going on. That's what the testing's for a situation like that. The idea behind the supply duct system is that it's a high induction system, meaning that it's taking air from the space. As the air is being pushed out through each of those holes, it's creating a jet, and it's mixing the air in the space a lot faster. It's also designed to stop stratification. So when you're tempering the air, it's moving the air from the ceiling into the space. Same with cooling, it's maintaining a flow. The cooling's not just dropping to the floor in a single location.
Instead of basically having the air come out of just the diffusers, it is allowed to escape the duct along the entire length. This allows it to mix more evenly throughout the space. We can precisely supply the air where we need it to be in a very specific pattern, a very specific velocity.
Supply duct is not a one-size-fits-all product, and there has to be engineered product for different applications.
We have a module that allows you to size specific supply duct systems. You'll see a piece of ductwork and very specific engineering feedback so that when you integrate these into the workplace, what we say it's going to do, that's what it's going to do.
The industry is very used to specifying diffusers, grills, flexible duct. We're thinking about getting rid of all those components. And once people grasp onto that idea, the solution is actually flawless.
So it's very important that we integrate these new systems together and not integrate new systems and have to deal with the old, because those old systems have a direct impact on the performance of new products.